if you were to solve this quadratic, it really is the same as solving for x. We could divide both sides by 2/9. We can square root and get an answer. The answer for this problem, which we're going to talk about tomorrow, not this specific problem, is actually calculating an answer. First, we're going to talk about how to find the solution of a quadratic. Okay? So a quadratic equation, up until this point, you've just been working with quadratic functions. You've been graphing them. We know the properties based on the format ax squared plus bx plus c. Today we're going to start to transition our conversation into quadratic equations. A quadratic equation is the same format, ax squared plus bx plus c equals 0. Now this should go without saying, but in a quadratic equation, the coefficient of that x squared, that a value, cannot be 0. Anyone know why the a value can't be 0? To represent our quadratic equation? What won't it form? What kind of line? What's the problem with this equation? No matter, think about whatever number. What's the problem if this is a 0? Would it be though? We didn't substitute in a 0 for x. We substituted in a 0 for a. That coefficient of x squared.
It won't open up or down.
Why not?
Because you can't have a positive or negative 0.
You're on the right track. What kind of equation is it if I have 0x squared?
Just a linear.
It would just be linear. If I had 0x squared, my equation just becomes bx plus c. That's a linear equation. So it wouldn't be a quadratic. Right? It is something that's specified in the technical definition of a quadratic equation, but hopefully that part would make a little bit of sense to you. If you don't have a term that has x squared, then it's not quadratic because there's no exponent of 2. Now, this is in standard form. This is the standard form of a quadratic equation. We have that ax squared plus bx plus c equals 0. The equals 0 is key because as we start to solve, we need that side of the equation to be 0. Yes.
Why do we have equal 0 instead?
That's the standard form of a quadratic. As we start to solve, you'll see why 0 matters. So one way we can solve a quadratic, and it's the best way to transition from graphing to just solving, one way is to actually graph the function. If we wanted to graph ax squared plus bx plus c equals 0, we can go back to what we did last week. And we can graph the y equals ax squared plus bx plus c. Again, you're just writing down a generic form of the quadratic function / equation. You'll have real values there. So the solutions. Now that we can talk about solving, we can identify what the solutions are. The solution of a quadratic is where it crosses the x-axis. The solutions for the quadratic are the x-intercepts, where this line crosses the x-axis. So based on that image, how many solutions does that quadratic have? 2. What are they? -2 and 2. So this solution would be represented by x equals -2, and this solution would be represented by x equals +2. When you graph, especially in that situation, since they're whole numbers, you'd easily be able to identify the solution. And we'll work on that for today. By Wednesday, we're going to start to solve by factoring. You'll find the values where that graph would cross. If I'm on the x-intercept, what is my value for y? 0. And that's going to come back in when we start to solve quadratics using factoring.
And that's our next one after this.
So there's a few ways we can solve quadratics. Today we'll focus on solving by graphing. Tomorrow we're going to focus on solving by finding the square root of an equation. Wednesday we will solve by factoring, which we'll probably do for the remainder of the week. Next week we will work on, before spring break, solving by completing the square, and we'll work on solving by using the quadratic formula. All of which will give you an answer.
And
Now the positive is that worst case scenario, always, the quadratic formula can always be used. And what that consists of is like the value, if you have an equation, the value of A, B, and C are being plugged into a formula. You are given that formula on the park exam. So even it's like the last thing that we'll do in
Is this
terms
like
of solving a
before?
quadratic.
Like each one was for that specific thing, and then like there was that one that was like for everything.
Mm-hmm. Yeah. Yep. So we can have a few different types of solutions for a quadratic. This quadratic in the picture has two solutions because it crosses the x-axis 2 times. We also could have a quadratic with no solutions. Picture what that would look like. What would it mean for a quadratic to have no solutions? It would never what? It would never cross the x-axis. So imagine what it would look like above it, moving up, or below it and moving down.
Yeah.
We also could have one solution. What would it mean for a quadratic to have one solution? Does it have to be the origin? What would it look like if the quadratic only had one solution?
The vertex would be on the x-axis.
Yeah, only the vertex would be on the x-axis. We're going to take a look at that in just a moment. So the solution, while it is the x-intercepts, they have other names. And the reason I like to bring this out early is most of the time you're not going to be asked to just solve the quadratic. Most of the time you will be asked to find the roots of the equation. So that is another name for the solution of a quadratic, the roots of the equation or the zeros of the function. So those are two phrases that you will most commonly see when it comes to solving a quadratic. And I try to use them as often as possible because you'll notice when we start to do a new park packet, most of the time they ask you for the roots of the equation or the zeros of the function.
No.
Sorry. Now, if you take a look at the actual solutions in that image on the left-hand side where x is -2, it says to solve x squared minus 4 equals 0, graph y equals x squared minus 4. The solutions of x squared minus 4 equals 0 are the x-intercepts 2 and -2. You might already notice a relationship between the solution and the fact that x is 2 and -2. You've already identified that in order to be a solution, the value for x would be when y is 0. So that kind of answers your question. Instead of having y equals x squared minus 4, if y is 0, we can try and solve for x. That's really the core solving for a quadratic. Tomorrow we'll start to actually calculate. Today we're just going to identify the solution in the graph. Tomorrow we'll solve.
Oh, okay.
Right. For example, tomorrow what you'll see, to get x alone, we add 4 to both sides, 4 equals x squared, and you can actually solve. That's where we'll go tomorrow. And -2.
Oh, because okay.
Yep. Keep me fancy. Okay, so if we had this quadratic, x squared minus 1 equals 0. If I were to graph this, I would graph the function y equals x squared minus 1. Think about what we know about this quadratic right away. What is the axis of symmetry? If I have my format for a quadratic, which term determines my axis of symmetry? Which one? The middle term. So where is that here?
Negative.
I don't have that middle term there. So when we first started graphing the quadratic, if we didn't have that middle term, where was our axis of symmetry?
They
What
cancel each other.
axis is that? Yeah, our axis of symmetry would be the y-axis. Right? And when we first started graphing, even though it's only a week ago, we started all the graphs that we did when we just started graphing the ax squared and then the c value. They were all on the y-axis. So we have our axis of symmetry. What's the vertex? In this graph, our vertex is also going to be what?
On the y-axis.
So what will it be if our axis of symmetry is our y-axis? It's going to be -1. What else is that in terms of our equation?
The c value.
Which is,
The now I'm tongue tied.
it's the c value, it's our vertex. In this situation, it's also representing what?
What is that?
Look back to your notes. What does that c value represent for a quadratic?
Y-intercept?
Not always the y-intercept, right? In this situation, because our axis of symmetry is the y-axis, this serves two purposes. It's not just the vertex, it's also the y-intercept. What do I know about the graph? In direction. It's going to go up, right? So how many times will it cross the x-axis? It'll cross twice. Right? Now, if I needed to find a solution, I could create a table. When x was 0, we already knew that y was -1. When x was 1, what was y? 0. When x was -1, what was y? Also 0. These represent the solutions. Okay, and you can see that coordinate. X is -1, y is 0. X is +1, y is 0. When you're graphing, you'll see them. You'll see the points. But to find the actual values, if you were utilizing a table, you would need to know the values where y is 0. That can get a little tricky, right? Because there's a chance that your solutions could be like -1.75 and x equals 2.15. I'm just throwing random numbers out there. There are other ways to solve the quadratic if you can't easily visualize the solution. Today we're just focusing on getting comfortable with the number of solutions and what they look like. So without solving, take a look at that equation. X squared plus 1 equals 0. How do you know that it has no solutions? Think about the equation and think about what each component of the equation represents. If you had to visualize that graph in your mind, what does it look like? How do you know that it has no solutions? There's two factors of that equation that indicate that there will not be a solution. Eric, what are they? I feel like you're trying to say it. Why won't that have a solution? Explain. Yeah, the parabola is going up, and I know the parabola is going up. How do I know that? Because this coefficient is positive, so I know it's going to open up. What else do I know about it? Where's the vertex? +1. If the lowest point of my parabola is above the x-axis, and in addition to that, my graph is going up, there can't be a solution. It will never cross. So it's two things that have to work together. If my y-intercept was a negative number and my parabola was going down, also would have no solution. And so it's a combination. The y-intercept matters, and the direction of the parabola matters as well.
So
You can tell in this equation that there will be no solutions for two reasons. First, the y-intercept is above the x-axis. Now that alone does not mean that there will be no solution, because what if the y-intercept was above the x-axis and then my parabola opened down? It would cross. The second part is that the parabola is opening up. On the flip side, if you had a y-intercept that was negative, and a parabola that opens down, it also would have no solution. That's why we spend so much time when we graph just understanding the components of the equation and what they do to the quadratic. What makes it go up? What makes it go down? Where does it cross the y-axis? Is it skinny? Is it fast? That'll help you also try to estimate some of your solutions if you know it's going to be a really wide parabola versus skinny.
So this applies to all the time.
Yes.
So it has to meet that criteria all the time.
Yeah, that would indicate no solution if it never crosses. And you'll get comfortable as we go with things that can never cross. You'll notice here, visually, that never crosses the x-axis. When we start to solve using calculations, you'll notice that there are some that just cannot be solved. Meaning like something times itself equals negative 25. That's not possible, right? We don't have a number that I can square that would give us negative 25. It could be positive, but not negative. If you came across that situation, and you'll notice when we go through, that would be no solution. And if you had to sketch a graph really quick to see it, you'd be able to identify it visually as well. Okay, so we're gonna try a couple, and I want you to first look at the equations, see if you can make an assumption on if there would be two solutions, one solution or no solution. And then I want you to actually find the solutions. Think about how we find coordinates on a graph. You can do that here.
No.
Oh, I'm sorry. What? Why are we so giggling? Is there something on? You good? Okay. So I want you to take a few minutes and identify how many solutions each quadratic has. Could you determine it without graphing? If so, how? And what are the solutions for those that have them? Let's take like 6 minutes. I'm going to pause the video while you're working on these, and then we'll go over them before the second half of class.